Hello again. So in this video we are going to look at small sample distributions, and what I meant by that is, as I said before, what if the number of samples were small? And if that happens, then it's really hard to use a normal distribution because of the kurtosis that may occur. And as I said last time, the way for us to handle kurtosis is for us to use the t-distribution. So in this video, I'm just going to give to you an experimental view of the t-distribution given certain parameters. So first, let us plot a standardized normal distribution. So I said before that for you to standardize a normal distribution, your mean needs to be 0 and your standard deviation needs to be 1. And if that's the case, then the values of the z-score, or you can just call it an x statistic, because remember, anything that you put on the distribution function is a statistic, so you can call it an x statistic. Alright, don't get confused, because before I was always mentioning that it should be a mean x bar I, right? But that is only the case when your normal distribution is corresponding to a sampling distribution. But remember, any kind of distribution can be normal as long as we know it is. But remember that the central limit theorem just makes everything normal. So in this case, we're just going to talk about a generic standardized normal distribution. Alright, now that's out of hand. Let us fill this in by what we know. So I put an equal sign, a normal, choose a normal distribution. You know what to put in here. You're supposed to put the x values. You're supposed to put the mean. Make sure that that's not going to move, and you can do that by putting a dollar sign. Let's remove my mouse. Dollar sign right there, and the SD is an X. Oops, sorry. Put the cursor right there. Put a dollar sign. Put a dollar sign, and finally, you need to make sure that the cumulative is false. You only use the cumulative if you wanted to know the probability, but if you wanted to plot the distribution, let us not put true, let's put false. Alright, press enter, and as you can see that my x statistic goes from -3 down to 0, and down to positive, oops, too fast, +3, as you can see. Alright, so if I double click on this, it should give me all the values until +3. We don't need to really look at that because we can confirm that in the graph anyway. Now let's do the t-distribution. Or how do we do the t-distribution? Well, it's an equal sign type t, and this thing comes out t-distribution. What we need is the x values again. Degrees of freedom, we will talk about that later, but it is actually related to your number of samples. So if I put 30, let's see what happens. But as I said, it is not exactly the number of samples, it's just related to the number of samples. But let me try to put 5. Alright, so it means that it's related to 5 samples only. We're not talking about sample size, we're talking about samples. And again, the cumulative we need to put false because we don't want a cumulative distribution. Press enter, and that's the value right there, and double click. Now, the aim of this video is to show to you what the graph looks like when the degrees of freedom is 5. So I am going to make another variable here called the degrees of freedom. Alright, I'll make it 5, and I'll make sure that this is reference to that 5. Make sure that that is going to be a dollar sign and a dollar sign. And press enter and double click on it. Alright, so here we go. I'm excited. I want you to see that. I would highlight the entire thing until I reach number 3, and so I highlight that, and then I need to press insert. I need to press insert right here and go to the scatter plot, and I would choose, I might choose this one. Alright, wait a minute. So I just did enlarge it, and look at this. Look at that. Such brilliant, very brilliant. Now let me give to you a taste. Select data just for me to change the name. I will edit it. Series 1 is the normal distribution. Okay. And series 2 is the t distribution. Okay, so now I'll press OK. There we go. Let me just find where my graph went. Alright, here's my graph. Now I also want to remove the dots so it's easy for us to compare. Let me just see here. I think I can change the chart style and see what happens. I wanted to just see lines. I don't think I could do it here. So let me just... There you go. Alright, so I've changed it. Now, what can you see? As I said before, the t-distribution would have a thicker tail. And that is confirmed. The yellow, the orange is the t-distribution. You can see a thicker tail on it, isn't it? But almost certainly the same in some parts. But let's try to increase this to 10. Let's see what happens. Increase the degrees of freedom to 10. Oh, that is so nice. You can see that the peak approximates almost the peak of a normal distribution, and also the tail slightly converges also to a thinner tail. If I increase that further to 30, oh, that is nice. As we understood, if the number of samples is 30, then it approximates very well the normal distribution. If I change that to 31, almost there. Maybe if I change it to 40, let's see what happens. That is an exact fit. Exact fit. Alright, now let me bring it down to 3. There. You can really see a dramatic change, and as I said, the tails are really thicker for the t distribution. Let's change that to 1. Let's see what happens. Oh wow, yeah, that is really nice. So the t distribution for 1 degrees of freedom, it has a really thick tail and a lower peak. If I change this to 0, let's see what happens. Oh, it's a flat line, of course. It's a flat line because it means you don't have any sample. Of course, if you don't have any sample, then you don't have any distribution.